Daniele holds a PhD in chemical science in the University of Siena. After a postdoc period in the same university, he has spent 2 years in a biotech company, and since 2017, he's covering the role of project manager and next technology techno-testing in Prato. The floor is yours.
Thank you for the introduction, and thank you to Patrizia and Maria Beatrice to invite me to this conference. It's really a pleasure also to show you today the results of another European project, because I think that we could also establish some synergies also with the ECOFUNCO consortium. So, just to say that Next Technology is a public-private research organization recognized by the Italian Ministry of Research, Education and University, and we are located in Prato, that is one of the main textile districts in Europe, and our main goal is to improve the competitiveness of companies. And according to that, we have established different and many collaborations among Europe, and so we are more active in European project and project at national and regional level. So I will introduce just today a project that was founded in 2019 and will finish just at the end of this year. The project FISH4FISH starts from a biorefinery approach in order to develop a new packaging material for fish. So the project starts from the need to reduce the plastic pollution of the environment that is related to the use of different plastics that are connected to packaging materials. So it means that a lot of polymers like polypropylene, polyethylene, and for which the material consumption is still increasing. And so, according to that, the idea is to find a new solution for the market, a new solution that are sustainable solutions and for which we could think to include some additives and fillers that comes from bio-based material and mainly waste materials to improve the functionalities of biopolymers, for which we know that are more sustainable, but for which there are still some limits in terms of applications. And sure, when we are developing materials for packaging and the primary packaging, as in the case of FISH4FISH, we need to take into account also aspects like food contact and barrier properties. So, the project starts from the concept of a shell biorefinery, because there are a lot of crustaceans that are consumed in the world every year, and the idea is to establish a new processing of this type of materials. It means that once this material is waste, we could think how to extract added value from this material. And so, as you know, from different crustacean shells, we can find different compounds that could, for which we could think to different industrial applications. So we have calcium carbonate, chitin, and protein as main components of this material. And for sure, the idea is to transform these compounds in added value products. According to that, as we know, the project was focused mainly on chitosan, and for which chitosan we know a lot of interesting properties, like anti-inflammatory, antimicrobial, could be used for wound healing, analgesic, and is also a biodegradable compound. It's really a quite interesting polysaccharides. For sure, chitin could be also transformed in chitosan and keto-oligosaccharides. This is one of the goals of the project itself. So, going into detail, the project starts from 3 different targets that we would like to reach at the end of our projects. Develop an active packaging to reduce the microbial spoilage and also to enhance the fish shelf life. Develop high-performance materials, so not only in terms of mechanical and barrier properties, but also to maintain the quality of food. And to have a final material that could be biodegradable and compostable, just to be used as fertilizer, and also to include in soil microbial preservatives for the plant growth. As you know, also chitosan has also interesting properties to support the plant growth. So just to say that the project starts from the chitosan production, but for which we have obtained different molecular weights and the acetylation degrees. These activities was performed by XIC from Madrid, and they have developed different possibilities in terms of chitosan molecules. This collaboration was also activity was also performed in collaboration with ANFACO, that is also in Spain, that is well included in the biorefinery approach in order to extract added value compound from fish's biowastes, and also to interesting application on food packaging. So after the extraction, we have produced different chitinolytic oligosaccharides, but as you know, has also improved antimicrobial activities, also better than chitosan itself, in order to include these compounds inside the blend, the new biobased blend formulation. Sure, also here we have used an enzyme approach through separation and concentration, and finally dialysis and lyophilization step. Once obtained the chitinolytic oligosaccharides, the idea was to include, as I said before, together in a new blend with bio-based plastics. But we have think how to protect chitinolytic oligosaccharides, because if you go to a conventional extrusion process, probably we have think to lose the antimicrobial properties. So starting from this concept, the idea was to create a nanofiller starting from lignin and create a layer by layer filler together with the chitinolytic oligosaccharides, and also obtain this type of filler. But as you know, also lignin comes from waste from pulp and paper industries, also from a biorefining industry. The idea is to use this lignin nanoparticle that was prepared by a nanoprecipitation technology to be blended together with a biopolymer, and to develop bioplastics for packaging realization using conventional technologies. So according to that, the project goal was to develop the not toxic compounds that could be included in the final formulation of the plastics. And sure, the target was to have similar properties to conventional fossil-based materials. So in terms not only of mechanical properties, but in terms of also barrier properties. And sure, the end of life of this material could be quite good in order also to improve the nutrient enrichment of soil, and also protect and improve the growth of plants. For this specific activity at NTT, we have used 2 different pilot lines to functionalize and improve the properties of the material. We have used e-beam technologies to induce a cross-linking inside the materials, taking into account also the cross-linking effect of lignin itself, in order to establish a network inside the material to improve the mechanical properties, but also the barrier properties. And another technology that we have applied is a plasma coating under vacuum condition in this case, and we have deposited a nanolayer of silicon-based compounds to improve the hydrophobicity of the material. Because sure, we have considered that we could use fish as a wet food, so we should also limit the water permeability. So the project is included in the plastic reduction strategies in order to preserve also our coasts and seas, and also to protect the environment. For sure, the idea is also to improve the value for fish industry's waste, because we are establishing a new possible application of this material, and improve also the competitiveness of fish processing industries, and also a reduction of food waste, a food waste that is not competing with conventional food that is cultivated in our fields, and also to have to improve the soil health and to have a high quality compost to enrich the soil. So this is the network that we have established. Is really good partnership, and we have obtained a good result that will be presented at the end of October. And so I will thank you, the project coordinator, that is the University of Siena, and all the other partners, Italian partners and the partners from Spain. Thank you very much.
Thank you, Daniele, for your very interesting talk and presentation of the FISH4FISH project. I think we have time for a couple of questions, so Juan.
My name is Francisco Villaplana from KTH. You saw me today. Thank you very much for the very interesting presentation. I was actually wondering, of course, about the enzymes, the chitinases. So, well, chitin is a semi-crystalline, quite tough material to be deconstructed into oligos. I was wondering, two questions maybe, how much of the chitin can be actually effectively depolymerized into the oligosaccharides? And yeah, how do you overcome precisely this crystallinity of the chitin?
Okay, I'm not a biotechnology, but I can try to reply to your curiosity. So, in any case, yes, we are trying to optimize the process and also the yield to obtain a chitinolytic so sure, using chitinases. In any case, we are using a small amount of chitoligosaccharides to develop the nanofiller together with lignin, because it's a layer by layer structure. So according to that, as I know at the moment, is a little bit expensive to produce this type of chitoligosaccharides. In any case, in our blend, and also according to the purpose of the project, it is a research project, so it's not an innovation action in this case, we have demonstrated that it could be possible. And really, the properties are quite interesting. And in any case, we are developing a blend using also chitosan, lignin, starch, and other biopolymer to have a completely banned biobased and with active properties.
Thank you. I mean, these chitoligos, I mean, maybe you produce them in small amounts, but they're very, very active, so maybe the price can be very, very interesting.
For sure, it's quite interesting that you should use really a low percentage, but to have a higher effect in terms of antimicrobial properties and to maintain the fish shelf life.
Okay, we have time for any other question from the audience. So I have a very short question from myself. I think it's out of the scope of the project, but if you have any data about comparison with other chitin or chitosan sources, I mean fungi or other, I mean in comparison with the properties you obtain from this project?
We will work on it, yeah. one of the ideas is to have a comparison, as you just clearly said, that there are different sources of chitin. So could be also quite interesting also to evaluate the antimicrobial properties.
Yeah, I think it could be a very interesting idea for the future.
So it's this was founded in the European Fish Maritime Foundation, so probably it could be just a baseline for the next projects.
Okay. So any other question? No questions. So thank you again, Daniele, for your presentation.